Let us know today what are isomers. Isomers are the compounds which have same formula, but in reality they are different compounds. Isomerism in coordination compounds. Coordination compounds, they have one metal ion at the center and it is bonded to different molecules or ions carrying at least one lone pair called ligands. These coordination compounds show interesting properties. Isomerism is the phenomenon wherein compounds with similar formula display different properties. Broadly, isomers are of two types. One is structural isomers, the other one is stereoisomers. Structural isomers arise due to different arrangement of ligands around central metal ion. They have several subtypes, such as coordination isomers. Coordination isomers have anion as well as cation in the form of complex ions, and we say that either we change central metal ion or ligands around a particular central metal ion. So the necessary condition for a compound to show coordination isomerism is it's both the ions, that is anion as well as cation must be complex. The other one is linkage isomerism. Linkage isomerism occurs when an ambident ligand binds through one of the donor atoms. For example, if we can consider the case of nitro ligands, which can bind either through N or through O, or cyanide ions, which can bind either through carbon or nitrogen. Ionization isomers, they give different ions in solution. So to create examples of ionization isomers, we should interchange ligand with counter ion and vice versa. Hydrate isomers, they are a typical case wherein water is interchanged with the counter ion. So in one of them water will be acting as ligand, in the other one it will be acting as water of crystallization. So this figure shows the examples of ionization isomers, linkage isomers, coordination isomers and hydrate isomers. Stereoisomerism, it arises due to different relative arrangement of ligands around central metal ion. They are broadly of two kinds, geometrical isomers and optical isomers. Geometrical isomers, they differ with respect to the position of similar ligands around central metal ion. If they are adjacent to one another, it is called a cis isomer, and if they are opposite, then it is called a trans isomer. Optical isomers, they are the ones which show optical activity, that is they change the plane of polarized light, and for a compound to be optically active it should be asymmetrical, that is it should not possess plane of symmetry or center of inversion. If one of the enantiomers, that is optical isomer, is dextrorotatory, then the other one will be levorotatory. Let us know today what are there are some examples of